differentiating functions with two or more terms. So, in my previous PO Maths video, we learned how to differentiate x to the power n, ax to the power n and how to differentiate quadratics. Now today, let's take a look at how to differentiate functions with two or more terms. If y equals fx plus or minus gx, then the derivative dy over dx equals f dash x plus or minus g dash x. Now, let's take a look at a few examples. Find the derivative dy over dx when y equals 3x squared times x squared plus 2x. First, expand the brackets before differentiating. So, multiplying each term inside the brackets by 3x squared gives us y equals 3x to the power 4 plus 6x to the power 3. I've already covered about expanding brackets in one of my previous PO Maths videos. If you want, check it out for more details. Now, since there are more than one term here, we can start by differentiating the terms one at a time. So, starting with 3x to the power 4, to differentiate 3x to the power 4, we multiply the constant 3 by the power 4 and then subtract 1 from that power. Then, 3 times 4 times x to the power 4 minus 1 equals 12 times x to the power 3 equals 12x to the power 3. Now, differentiating 6x to the power 3 gives us 6 times 3 times x to the power 3 minus 1, as we multiplied the constant 6 by the power 3 and then subtracted 1 from that power. Then it's 18 times x to the power 2 equals 18x to the power 2. Then the derivative dy over dx of y equals 3x to the power 2 times x to the power 2 plus 2x is dy over dx equals 12x to the power 3 plus 18x to the power 2. Now, y equals 3x to the power 2 minus 6 over x. First, express the single fraction as two separate fractions and simplify. That is, divide 3x to the power 2 minus 6 by x. Then, y equals 3x to the power 2 over x minus 6 over x equals 3x minus 6 over x. Now, before differentiating, we need to rearrange this term in the form ax to the power n, where a is a constant and n is a real number. Then, y equals 3x minus 6x to the power minus 1. Now, since there are more than one term, we can start by differentiating the terms one at a time. So, starting with 3x, here the power of x is 1. So, let's say 3x to the power 1. Then, to differentiate 3x to the power 1, we multiply the constant 3 by the power 1 and then subtract 1 from that power. Then it's 3 times 1 times x to the power 1 minus 1 equals 3 times x to the power 0. X to the power 0 equals 1, then 3 times 1 equals 3. Now, to differentiate minus 6x to the power minus 1. Then it's minus 6 times minus 1 times x to the power minus 1 minus 1. As we multiplied the constant minus 6 by the power minus 1 and then subtracted 1 from that power. Then it's 6 times x to the power minus 2 equals 6x to the power minus 2. So, differentiating y equals 3x to the power 2 minus 6 over x gives us the derivative dy over dx equals 3 plus 6x to the power minus 2. Now, y equals 2 over x to the power 3 plus the square root of x. Now, before differentiating, we need to rearrange each of these terms in the form ax to the power n, where a is a constant and n is a real number. So, 2 over x to the power 3 means 2x to the power minus 3, and the square root of x means x to the power 1 over 2. So, y equals 2x to the power minus 3 plus x to the power 1 over 2. Here, this term is in the form ax to the power n and this term is in the form x to the power n. Now, since there are more than one term, we have to differentiate the terms one at a time. So, starting with 2x to the power minus 3, to differentiate 2x to the power minus 3, we multiply the constant 2 by the power minus 3 and then subtract 1 from that power. Then it's 2 times minus 3 times x to the power minus 3 minus 1 equals minus 6 times x to the power minus 4 equals minus 6x to the power minus 4. And to differentiate x to the power 1 over 2, we multiply by the power 1 over 2 and then subtract 1 from that power. Then it's 1 over 2 times x to the power 1 over 2 minus 1 equals 1 over 2 x to the power minus 1 over 2. So the derivative dy over dx when y equals 2 over x to the power 3 plus the square root of x is minus 6x to the power minus 4 plus 1 over 2 x to the power minus 1 over 2. Now let's take a look at a few more examples. Find the gradient of the curve with the equation y equals x times x plus 1 at the point 0, 0. So, I've already covered about how the gradient function or derivative can be used to find the gradient of the curve for any value of x in my previous PO Maths video. If you want, check it out for more details. Now first, we need to differentiate to find the gradient function. So first I'll expand the brackets, then y equals x to the power 2 plus x as we multiplied each term inside the brackets by x. So, differentiating the terms one at a time starting with x to the power 2. To differentiate x to the power 2, we multiply by the power 2 and then subtract 1 from that power. Then it's 2 times x to the power 2 minus 1 equals 2 times x to the power 1 equals 2x. Now, to differentiate x. So, here the power of x is 1. So, differentiating x to the power 1 gives us 1 times x to the power 1 minus 1 as we multiplied by the power 1 and then subtracted 1 from that power. Then it's 1 times x to the power 0. X to the power 0 equals 1, then 1 times 1 equals 1. So, the gradient function or derivative of y equals x times x plus 1 is dy over dx equals 2x plus 1. Now, since the gradient function can be used to find the gradient of the curve for any value of x, in order to get the gradient of the curve with the equation y equals x times x plus 1 at the point 0, 0, we substitute the x coordinate value to the gradient function. In this case, 0. So, substituting x equals 0, dy over dx equals 2 times 0 plus 1 equals 1. So, the gradient of the curve with the equation y equals x times x plus 1 at the point 0, 0 is 1. Moving on to another example, find the coordinates of the points on the curve with the equation y equals x to the power minus 1 plus 4x where the gradient is 0. Now first we need to differentiate to find the gradient function. So, differentiating the terms one at a time starting with x to the power minus 1 gives us minus 1 times x to the power minus 1 as we multiplied by the power minus 1 and then subtracted 1 from that power. Then minus 1 times x to the power minus 2 equals minus 1 x to the power minus 2 equals minus x to the power minus 2. Now 4x. Here the power of x is 1. So 4x to the power 1. Now to differentiate 4x to the power 1, we multiply the constant 4 by the power 1 and then subtract 1 from that power. Then it's 4 times 1 times x to the power 1 minus 1 equals 4 times x to the power 0. X to the power 0 equals 1, then 4 times 1 equals 4. So the derivative dy over dx of y equals x to the power minus 1 plus 4x is minus x to the power minus 2 plus 4. Now, we know the gradient function or derivative can be used to find the gradient of the curve for any value of x. Now here, since we know the gradient is 0, we can put the gradient function equal to 0 and then solve the resulting equation to obtain the x-coordinate of the point where the gradient is 0. So, setting the gradient function equal to 0, minus x to the power minus 2 plus 4 equals 0. So, minus x to the power minus 2 can be written as minus 1 over x to the power 2. Then minus 1 over x to the power 2 plus 4 equals 0. Now solving this equation gives us 1 over x to the power 2 equals 4. 1 equals 4x to the power 2, x to the power 2 equals 1 over 4. Taking the square roots from both sides of the equation gives us x equals the square root of 1 over 4. X equals plus or minus 1 over 2. So x equals 1 over 2 or x equals minus 1 over 2. Now, to find the corresponding y coordinates of these points, we can substitute the x values to this equation. So, we can rewrite this equation as y equals 1 over x plus 4x. So, when x equals 1 over 2, y equals 1 divided by 1 over 2 plus 4 times 1 over 2 equals 2 plus 2 equals 4. And when x equals minus 1 over 2, y equals 1 divided by minus 1 over 2 plus 4 times minus 1 over 2 equals minus 2 equals minus 4. Then the coordinates are 1 over 2, 4 and minus 1 over 2, minus 4. So the coordinates of the points on the curve with the equation y equals x to the power minus 1 plus 4x where the gradient is 0 is 1 over 2, 4 and minus 1 over 2, minus 4.